Let me share my screen. So, do you want to start first by me explaining the twoD, the pointers, or you understand them?
Sorry, just a minute. Yeah, so yeah, could you please start there by the 2 pointers, 2D arrays, how to create 2D arrays with pointers, and yeah, please.
Okay. I will start with the oneD array using pointer.
Okay.
Okay. This is basically how you declare it. Let me do this. So basically, a pointer is at the moment it's just something that holds a reference to memory, right? So now let's say we want this pointer to point to a space in memory, right? And you want that space that the pointer is pointing to contain an integer, right? So to do that, we need to allocate memory. So to allocate memory, we're going to say this goes to new, then int basically just specifies what kind of data type the space that this pointer is pointed to is gonna have, right? So if this thing we leave it like this will just basically pointing to a space in memory, and that space contains an integer. So now,
Yeah.
if we want this pointer to point to a group of spaces, it means we need to specify the size of those spaces. So we're just going to specify the size in square brackets after new int. So if we now look on that, this is the pointer, and now our pointer points to spaces that contains integers. So now those spaces, we now refer them to as a oneD array of integers.
Okay.
So now, in order to access each space, we use an index. So if we put a size of 10, the index starts from 0 and the last index ends at 9. So there won't be an index of 10. Of course, it will still be 10 spaces, just that the index will start from 0 and ends with 9. So do you get that right?
Yeah.
So let's say we want to put in some values in there. Just going to look through the array. Starts with 0. Array is less than the size. Okay. Then here we're just going to, for now, let's say we want to put ones everywhere. Just going to do it like that. So this is allocation and this is initialization.
Okay.
So
Sorry, could you please show the difference between showing, because from a theoretical point of view, a pointer is supposed to be pointing to a memory look to what is this? A memory address, right? So
yeah,
now, how does it differ with it pointing to memory location? So there's a bit of confusion there as well. Could you please enlighten me on that?
I actually didn't get your question.
Yeah, so basically I'm saying that a pointer is supposed to be pointing to memory addresses, right? But here you
Mhm.
just said that when you create a oneD when you create a pointer here, which you name oneD, and you basically ask for a new you basically ask for a new memory, right? So here you're saying that this pointer is pointing to memory locations of 10, or should I say nine different um, memory locations. So how does that differ from a pointer pointing to memory addresses? So basically, what do you do to make a pointer point to memory address instead of memory location?
Memory address instead of memory allocation. Okay. I'll actually try to do that as we go on.
Okay, sure.
So okay, but for now, let's just display this. For now, the oneD array now it just contains values ones, right, at the moment. So now let us just display everything.
Mm.
Okay. So the moment the array will just contain ones everywhere. Okay, so now before we terminate our program, we must always deallocate memory. So at the moment, we're just in the allocation memory, we're just deleting the pointer. So at the moment, we have one pointer, so we can just go ahead and delete it. So now, like you see in the world, this is an array of integers, right? But then when we display a world, for example, the practical 8 we just did,
Mm.
instead of displaying the actual values, we're just going to display characters instead. So a way to do that is by creating an array of characters. For example, mhm. Then I want to specify in some values. Let's say at index 0, I put a dot, and at index 1, I put a p. So now what I'm going to do is that I'm going to make a function to generate random numbers, right? So let me do that function in a header file. Just call it chaser. Define my namespace. Okay. The header file just show in the just show the function declaration or generate random. Then I'll pass in the abound abound and the lower bound. Okay. So you already know how to create the function to generate random numbers, right?
Yeah, you could just go and explain it, please.
Oh yeah, this function we just need to pass in the upper bound and the lower bound. So basically, if I want to generate random numbers from 1 to 10, I will pass that 1 as a lower bound and the 10 as an upper bound. So to create that function, to generate a random number, we need to first create a range. So range is basically upper minus lower plus 1. Then it's going to say rent, then modulus range. And we pass in the lower bound. So to use this rand, must not forget to include this std. Okay. So this is basically function to generate random numbers. We first declare the range, just say upper minus lower plus 1. Then you return range, then you modulus the range, then plus the lower bound. So in here, let's when we initializing the world, let's put in some random numbers instead. I'm going to yeah. Then here under initialization, I'll just generate some random numbers. I'll just generate random numbers from 10 to 1 for now. Now if I were to run my program, now my array would just be containing random values from 1 to 10. Okay. But
Okay,
then
okay. I was gonna ask what you start by saying, but I remember that you initialize the random number generator from upper and then lower. That's how you set the parameters of the function, right?
yeah, but if you want, you can start with lower and the second one be up. It doesn't matter.
Okay.
So now if I run this again, uh, the array for now will just be having some random numbers. But then if you notice something, if I terminate the program and run it again, the values will still be the same. It's 285,110. So it's 285,110. So basically at the moment, the function to generate random numbers will be generating the same random numbers all over again, right? So
Mm.
in order to deal with that, we need to switch the random numbers.
Random numbers, yeah. Using seed time, yeah.
Yeah. So just pressing the time and hit 0. Then now to use time, we need to have the header file seed time. Now if I run this, the values will be different each time I run it. Okay, it's good. So here I want to my array to only contain zeros and ones. Okay. So now instead of displaying those zeros and ones, I want where there is a 0, I want to display a dot, and where there is a 1, I want to display a P. So
Okay.
I'm going to have this array here, and index 0 has a dot and index P has a dot, right? Let me comment this
Wait,
display out.
sorry, could you please re-explain how you created the char characters array? Because it's a bit different from how you created the integer one.
This one.
Yeah.
So basically I'm just saying char, right? And
Mm,
there's an array of characters, then I give it a name.
mm,
Characters. and I just show that is an array by specifying those square brackets. Then same time I want to specify the values that are in this array of characters. So I'm just going to make the characters here. Then okay, to go to the next character, I separate it by comma. Okay. And basically this array of characters will only have a dot and a p. So it's index 0 and index 1. Okay. Let me display them. Let me say characters at index 0.
So basically, if I understand you correctly, it means that the number of characters that you'll be outputting within the curly braces will represent the number of
The
the
size of
member
this array.
yeah, the size of the array basically. So if, as you said, it's dot np, that means that the array will be a size
Yes, it will be
two,
specifying
right?
that the array will be of size 2. And then yes, the first index is 0 and the second index is 1.
Okay, so that's the convention for creating an array of characters.
Yes.
Okay.
And if I were to display whatever in the array, I'll just say characters, then put my index. So this is how I'm going to display them, right? Then if I will display them, I'll see a dot and a p, right? So here we're now here in the display of the oneD array. At the moment, our oneD array only contains zeros and ones, right? Just generated it here. So it only contains zeros and ones.
Yeah.
So instead of displaying those values, I'm going to use this array of characters. I'm going to say characters, then put this oneD array as an index to this array of characters. So since this oneD array only contains zeros and ones, it means it's either this returns a 0 or it returns a 1. Let's say it returns a 0. That 0 will now become an index to this array of characters, and a dot will be displayed. Do you get it?
No, not really.
So we have our oneD array, right, of integers.
Yeah.
And our oneD array of integers, at the moment, it contains zeros and ones, right? I initialized it to I generated random numbers from 0 to 1, right? So it only contains zeros and ones at the moment, right?
Yeah.
Okay, let me display this alone. So if I were to display it like that, I will only see zeros and ones. So now I want to, instead of displaying the actual values, I want to, where there's a dot, I want the dot to be displayed as a dot. Where there's a 0, I want to display the 0 as a dot, and where there's a 1, I want to display it as a p. You get that, right?
Yeah.
So you have seen that this array only contains zeros and ones, so which means it will only return a 0 or a 1, right?
Yeah. Yeah.
So I want to make this an index to this array of characters. Okay. I'm going to do the characters, and I'm going to make it an index to this array of characters. So if this oneD returns a 0, it means 0 will be the index of this array of characters, right? And a dot will be returned. If it returns a 1, that one will become an index to this array of characters, and
Okay.
the key will be displayed. So
Yeah.
you get it now.
Yeah, I get it.
So this is how it's going to be.
Okay.
So basically, that's our oneD array. So this is the deallocation here, the display. Okay, so now I'm going to do the twoD array using pointers, right?
Yeah.
So in order to do that, here we say in pointer, I'm going to call it twoD. This one people create it differently by the different one is by using a type def. So
Yeah. Could you please explain that as well, or the type def as well?
okay. So type def is actually like giving something a name. Like I can say that. So let's say instead of saying int pointer, let's say we want to give int pointer a name. Okay, we're going to say type def and we specify what we want to, the thing that we want to give a name. So we want to give int pointer a name.
Okay.
Then we're going to call it oneD. So instead of saying int pointer like this, we're just going to use its name we're giving it. Just going to say oneD. So this oneD will be representing int pointer. We're just basically using its name, right? And if you want this array to point to a twoD array, we're going to say int pointer. So this is the same as int pointer. We call it. So this thing and this thing are actually the same. The difference is that here instead of specifying int pointer, we just use its name. Do you get it?
It's a bit confusing. Could you please go over that again?
So type def using type def, it means like we're actually giving things a name.
Yeah.
I'm saying things because I can't think of a clear name to use. So here what we want to do is that we want to give int pointer a name.
Yeah.
So we're saying int pointer is called oneD.
Yeah.
So if we want to use an int pointer, instead of saying int pointer, we're just going to use its name. So its name is oneD. So here like we said oneD, right? So here it's just oneD is just a placeholder. So saying oneD is me saying int pointer right here. Saying oneD is me saying int pointer. So that I'm using int pointer's name instead of typing int pointer the way it is. So this will be int pointer. So it's the same thing. So int pointer. So here I'm just typing out int pointer as it is, then specifying the other pointer. So yeah, this is just int pointer, just that I'm using its name oneD.
Okay.
Do you get it now?
Yeah. Yeah. But then wait. When you say type def in pointer oneD, how does the compiler know that oneD is a pointer since you haven't specified that oneD is a pointer yet?
No, oneD is just the name. Just the name given to int pointer. It's
Okay.
not a pointer.
Okay. So it's the name of the pointer that's right.
Yeah, let me show another demonstration. Let me say if I were to declare a name of type string, right? I would say string name, but
Yeah.
then let me say I don't want to say string. I want to maybe to say str. So
Okay.
I'm going to declare a type def, then I'll give string a name, also I'll call it str. So
Okay.
here, instead of saying string, I'll just say str, then say name.
Oh.
Str is just string. That's that instead of just typing out string, I'm saying str.
Okay. Okay.
Do you get it now?
Okay. I get it. I get it. Okay. Okay.
Okay. So you choose what you choose. You choose which one you prefer to use. I would same thing. So I'll say int pointer pointer, and I will give it a name twoD.
Uh,
So you saw with how with an int pointer points to a oneD array of integers, right? So with int pointer pointer, it's going to be different. So in memory allocation, so now this pointer is going to point to an array of pointers. You see now we have int pointer pointer. So now this array is going to first point to an array of pointers. If we just had int pointer, we're just going to point to an array of integers, right? So now since we have int pointer pointer, it's going to first point to an array of pointers.
okay.
Let's try to see how that look. So this is the pointer. So now it points to this array, but then this array is not an array of integers. It is now an array of pointers. Okay. Just by specifying int pointer, we are saying it's an array of pointers. If it was an array of integers, we're just going to say int, then specify the size. So we said int pointer, it means it is an array of pointers, right?
Yeah.
So this means we now have to go to each pointer and allocate memory to it. Right. So how are we going to do that? Going to look through that array of pointers. Int r is equals to 0, and r is less than 10, r is plus. So we're going to go to each pointer. This is the first point, pointer at r. Then we're going to allocate memory to each pointer. So now each pointer in the array of pointers will now point to an array of integers. We're going to say the size is 10.
Okay.
So this, let me try to draw it. Now each pointer in this array of pointers is going to point to its own array of integers. So this pointer here is going to point to its own array of integers. Let me do that. So it's basically going to be something like this. So we first have an array of pointers. Then now we go to allocate memory to each pointer in this array of pointers, and each pointer will now point to an array of integers. Do you get it?
Yeah, I get it. I get it.
Okay. So now basically have something like this. So in order to access a value here, we need to know are the pointer here, and we need to know the index of each array integers, right?
Yeah.
So let's say we want to initialize the array.
Mm.
We basically need to know the index of the array of pointers. It's going to display that as an R. So then since each pointer has an array of integers, to access that array of integers, we need to know the index. So we're going to use C. It's less than the size C plus plus. So twoD. Let me change the name. So twoD at R net C. So let's just generate random numbers. 10 from 1 to 10. Okay, so we continue. You get it, right?
Yeah. Yeah.
Okay, this is the initialization. Now let's go to the display. So to display it, still the same logic. So like we first go to the row. The row is the pointer, right? Then we go to each index of in which the pointer is again the pointer is pointing to an array of integers. So
Yeah.
we go to that pointer, then go through its array of integers. So it's going to be going like this. We start from here, we go like this, then we go to the next row, then we go like that. So even the display is going to do the same thing. So
Yeah.
here I'll just use the same for loop. And will display each values. Yeah, I want after each value I want to put the space. Then when I go to the next row, I also want to go to the next line. Do this. So now I run twoD. Use the wrong name here. twoD. Okay. So if now I run, I'll just see the values of the twoD. So now we need to let's do the allocation of memory. So now since we have these pointers here and we have another pointer here, it means we must go and delete every pointer we have now. So
Yeah.
we need to delete every pointer that's in this oneD array of pointers, then delete this whole pointer that points to this oneD array of pointers.
Yeah.
You get it, right?
Yeah.
So okay, let's look through the array of pointers and delete each pointer. Okay, I'm going to go to each pointer and delete it. Okay. 2D R. So after deleting, you can say 2D R is equals to MR, and can do that if you want to. Then here, after deleting every pointer in this oneD array of pointers, we're going to delete this pointer now. The pointer that points to this oneD array of pointers. I'm going to delete it. Going to say delete. And if you want, you can say 2D is equals to null point. So do you get the allocation?
Yeah, I get the deallocation, but why didn't you delete because you only said 2D deletes array of 2D at R only. Why didn't you say at C as well?
Because C is just the oneD array of integers. We only delete pointers.
Oh, okay.
In the allocation, we only delete pointers. This is just the oneD array of integers. There's no need to delete that.
Okay.
So if you want, you can do this thing. It's cost to point, but I'm not going to do it.
Okay.
I know.
So
This. So let's say that's like we have in the game. Let's say we have spaces and we have players and we have a whatnot. So now, of course, we can't display the values as they are. So now, instead of displaying those values, we want to display characters. So this will still be the same logic as we
uh,
did last time.
sorry to interrupt. I just have one quick question. For you to create a 2D array, do you always have to do what you did on the top there for int r equals to 0 or just on the top there? Yeah.
This one,
Yeah. Do you always need to do that? What's inside the loop there? The 2D array at r is equal to int as 10. You always have to do that.
yeah, but then the sizes won't always be 10. The sizes can also be different. Yeah, you're, you're going to do the same thing, like going to be the same thing, just that the size might not be 10 for the pointers, and the size might not be 10 for the array of integers. Just need to understand why you are doing it and stuff and stuff. You understand it, right?
Okay.
Okay, so in the display, so I want my 2D array to only contain zeros and ones. So I'll just generate random values from 0 to 1. So here I want to, ouch. So my 2D array contains zeros and ones at this moment, right? So here I want to create an array of characters. It's usually the same thing. And I'm going to specify the values same time. Have a dot, and we have a P for player. So this is my array of characters. So where there's a 0, I want to display a dot, and where there's a 1, I want to display a P. So it's the same thing. So here, this 2D array contains zeros and ones. So I want that those values to now become indexed to this array of characters. Characters. So you already got it from the last explanation, right?
Yeah.
Okay, now if I run this is how my world is going to be. Because in an actual game, you need to have all the other objects, the obstacles, whatever the game wants you to have in the world. Okay, so this is just an example. So now I'm going to explain the command line arguments. So, you see how when we get an input from the user, we just be using cin. Let me explain the unit. So for the 2D array, you get it right.
Yes, so far I get it. Yeah.
So let's say we had an age and we had a name. So if we wanted this from the user, we're just going to use cin age name. Ouch. Name. And these things are going to come into our program exactly with their respective data types. If it's an integer and we're getting an integer, come as an integer. And if we want a string, come as a string.
Mm.
Let me see how these things after getting them. Let's say hello, Brian. You are. Okay. Just demonstrate that. I'm going to pass in an age, as a name, then I'll just go to display hello Brandon, you are 25 years old. So you see the age is an integer and the name is a string. So this thing, they come into our program exactly with their respective data types. But then with arguments, arguments only come into our program as strings, right?
Okay.
So arguments are also inputs, but then those inputs we get them from the command line. Let's say you see our C++ programs. Let's say we run our program with a command prompt. Command prompt is this thing, CMD, and let's say our program needs an input. So when we enter an input here, that input, when it goes into our program, it will go into our program as a string. You see, those inputs we get from this command prompt are called the arguments. We are referring to them as arguments, right? But then they come into our program as strings.
Okay.
So in code blocks, we have a way to pass those arguments. And we just go to project, then set arguments, and I'll just specify them here. Let me say I want to pass in a 20 number of columns and number of rows, and say, let's say this 20 is the number of rows and this 30 is number of columns. So arguments, like, you can consider them an array of arguments. Okay, so if you have two values here, let me show you how to access them. It's like you are having an array of arguments. So to access this value, I'm going to say the name of the array at index 1, and to access this one, I'm going to say the number of the index, the name of the array at index 2. Let me show you that before actually. So here in main, we're going to overload this main function. So to overload it, just going to say int argc. So argc will represent the size of the array of arguments. Then here we're going to have that array of argument. We say it's char pointer. Just going to call it argc. So this will be the array, and argc will be the size of this array. You get it right?
Could you please go over that again, please?
So in order to use a command line argument, we need to overload the main function. Just by doing this, we're overloading the main function, right?
Yeah.
So we're going to have two things. We're going to have argc and args, right? So argc is going to represent the size of the array, and args is just the array of the arguments. So arguments are just the inputs that we get from the command prompt. Then code blocks, we're just going to pass them exactly from code blocks, right? So to pass those arguments, we say project, then set program arguments. Then we're just going to specify them here. So let's say we want to pass in a 20, then we want to pass a 30. So you see here, in order to access this first value, we're going to use args at index 1, and to access this second value, we're going to say args at index 2. Okay, you get it, right?
No, not really. Why are we using char pointer?
Pointer is just a way to, what can I say, to specify that array of characters. Don't really need to know why you saying char pointer. Just know we have to use char pointer to for specifying the array of command line arguments.
Okay, so we basically have int argc and char pointer args. So which one is the because you said you look at it as an array. So is argc the first um the first what is it, the first index of the array, and then char pointer is the second index, is that it?
Now, actually, we're going to look again, as you said, we're going to look at those arguments as an array of arguments, right? So argc here will just be the size of that array of arguments. Then args will be the array of arguments. You get that? Args is just a size, and args is just the actual array. So in order to, so here we just go to project, then set program arguments, then we set those arguments. So here we only have two values. We have a 20 and a 30. So it means this array as at index 1, it has a 20, and at index 2, it has this 30. So, but then what does this mean for the size of this array of arguments? What do you think the size is going to be? So this thing, we're going to use the same logic as arrays. So for args at index 0 is going to be the name of the program, and args at index 1 is going to be the first value we specify here, and args at index 2 is going to be the second value we are going to specify here. So what do you think the size of the array is going to be, which is represented by argc? So remember when we allocating memory, right? We put in the size, but then we remember that to in order to get those the values in those oneD array. Like we specify the size as 10, but then to access the values, we say the first index is 0 and the last index is 9.
Yeah.
So here we have for args, we have the first index as 0 as the name of the program, and index 1 here is 20, and index 2 here is 30. So what do you think the size is going to be?
So it's going to be 3, I think.
Yeah, it's going to be 3.
Yeah.
So it's same logic as as the arrays. So now remember I told you that those arguments come into our program as strings. Yes,
Okay.
we passed an integer there, we passed a whole number there, but then when it comes into our program, it is not going to come as an integer, it's going to come as a string.
Okay.
So here let me declare some values to get those arguments. So let me say name first. So I said that the index at 0 is going to be the name of the program. So name is just going to at the moment our project is session 1. So name will just be we'll start with it will just start with the path, then at the end it will be the name of the program, which is session 1. Okay, now let's access those values in the command. So to say args index 1 string dot accent index project. So args at index 0 just be the name of the program. Then the first index will just be whatever we wrote here. So at the moment it is 20, and the second index will be 30. So this is how we access those values. This is how. So
Okay.
let me just display them. I'm going to start by displaying the size of the array. I'm going to say size. I can just I'm going to say axc. Go to the next slide and display.
But sorry, you said rows is args and calls us is args as well there.
I said what?
The rows you said args and column args as well.
So this is args at index 1, and this is args at index 2. So the value we have here is 20, right? So to access this value, we're going to say args at index 1, since it is placed the first, right? Then to access this second value, we're going to say args at index 2. So here when we say args at index 1, it's going to get this value. Then here when we say args at index 2, it's going to get this second value. Do you get it?
Okay.
You get it, right?
Yeah.
Okay, then here I'll just display the name. So the name is from index 0. Get it from index 0. Here. So here I'm just going to display them. So you see I've declared those things as strings. Yet I pass them as whole numbers, but I'm going to display them as I'm going to get them as strings because they come into our program as strings. So now if I run, you will see that now my size is 3. And for the name, this is just the name of the program. And rows is expected, it's 20, and calls is 30.
Okay.
You get it right.
Yeah. So basically, if I understand you pretty well, you're saying that the first index of arg S are represented as rows, and the second index of arg S are represented as columns, basically. And the zeroth index of arg S is the name of the program.
Yes.
Okay.
So of course here it can be anything. These values here can represent everything you want. It will just depend. This is just an example, right?
Yeah.
So like for
So
example,
since
mhm,
I just want to learn something. So since we do not display the zeroth index, we start by the first index, which is 20, which is a number of rows, and 30, which is a number of
mhm,
columns. Is that it?
yes, yeah, that is it.
Okay.
And yeah, if I were to add something else here, let me say Brandon, for example. So
Mm.
it means now my size will change. So my size.
Mhm.
So
Yeah.
since my last index here is 3, so it means my size, which is axis, will be 4.
Before, yeah.
Now if I run, you see it's 4.
Mm.
So you can also display that Brandon there. Mm, let me just do this. And let me just display it. I'll say so that is the third index, right? I can just do it like this just to display it. And I should now see Brandon. Okay, you see it right.
Yeah.
So yeah. So can just can just pass anything. Then you choose how you want to you choose what you want them to mean. So for us, we want the first value to represent the rows and the second value to represent the call. Brandon, just Brandon, right? So it depends on the code, the program you are creating, right?
Okay, but do you have to declare each values in main?
Yeah, you have to, like for example, you need to. So what you're saying, like you just want to use them like this, you
Yeah,
can
because I
just
mean, I
say,
saw you didn't declare arg S3 at index 3, but you could reflect on the command line. I mean, on the when you started the program.
yeah, you can just instead of having the variables, instead of declaring the variables, I can just use them like this, right? But then the purpose of declaring them. So I can remember I told you we get these things as strings. So let's say now we have a world and that's saying that the number of rows are passed from the command line argument. So it means
Mm.
it's going to be something like int pointer. Let me call it twoD, twoD. Let me say new int pointer. Then give the size. So let's say the size is the the number of rows, the first argument there. So it means I can just do it like this. So this thing would be wrong because arc as comes to our program as a string. So we can't we can't specify the size of an array with a string. It needs to be a data type of integer. So if I try to run this will give me an error because it's not possible to use a string. So even if let's say here we declare this as a rows, right? So let's say we want to loop through an array of size
Yeah.
rows. So int int r is equals to 0, then r. So same as well, we can say r is less than rows. and say R plus plus. We can say that because rows is also a string. So in order to loop, we need to use an actual a data type of integer. Yes, we pass it as a whole number, but then when it comes to the program, they come as strings.
Okay.
So what are we going to do with them? So what we're going to do is that we're going to get those arguments as strings, and we're going to convert those arguments to integers so that we can be able to use them. Because remember, in our programs from now on, we need to pass the number of rows, the number of columns, like basically everything. We're going to pass it from the command line argument. So in order to use them, we need to convert them to integers. So that's what we are going to do now.
Okay.
I'm going to create a function to convert strings to integers. Say convert to int. Then I'm going to pass in the string number. So have you done it yet in class?
What's that?
Have you done this function to convert a string to an integer in class?
Yes. Where you use the static thing.
Static. So in here, what we're going to do, okay, this is the function to convert a string to an integer. So we're going to pass that string. So at the end of the day, we want to have an integer. So I'll do this for now. Say return int. Let me check something. Coding, okay. So in order to convert a string into an integer, we need to have something called string stream. It's like this is string stream. It's like a data type. You can think of it as a data type. Then we're going to name it SS. So string SS is going to take in the particular string. But then before we can use string, we need to
Do the library.
we need to include the library, which is S.
That's a string.
Yes, S string. Yeah, it's S string. So yeah, string falls under S string. So we need to include that header file. So string, we're going to call it SS. You can call it anything you want. Normally we call it SS. Then it's going to take in a string. So that's what we're doing here. Okay, taking in the string. So it's going to try and convert this string into an integer. So we're going to do that in this line. So it's going to say SS. Then we use those insertion bracket and say int num. So what this line means is like taking, again, SS has this string as a number. So it's going to try to take that SS, that string number, and try to put it inside int num. Right? Do you get it? You get it right.
Wait. Could you please go over that again? What you just said?
So string, it is SS, right? So string SS is going to take in the string number, right? And here is going to try to take that string number and put it inside int num. Int num is of type integer, right? So
Okay.
if this string is like the whole number, let's say 21. So if it's a whole number, so remember integers do whole numbers. So it means this will be successful. So 21 will be successfully be put inside int num, right?
Yeah.
So
Yeah.
so it means the conversion will be successful. So, but then let's say someone, instead of passing a whole number, just passes maybe an actual text, like some ways. So maybe he was supposed to pass 21 as a number, and he passed 21 like in ways. It says 21 tw like that. So when that thing comes here, it will try to put it into in int num, right? But then int num only contains whole numbers. It cannot contain strings like actual words. So it means this thing will fail, right? So in order to check for such occurrences, in order to check if a conversion has been successful or has failed, we say if ss
SSC fail bracket.
We're going to do that to check if the
Yeah.
convention has failed or not, right?
Mm.
And if it has failed, we're going to output an error message. Maybe say failed to convert string num an integer. It's going to be like that. Then now, so imagine if we wanted to have a number of rows. Now the person just passed something differently. It means now we won't have the number of rows. But then if now our number of rows are supposed to be important to our program, so it means we can't continue with our program if we don't have those number of rows. So just going to exit the program. So yeah, the error code, I'm just going to put -1. Okay, then if the conversion was successful, we're just going to return the int num, which will be having the whole number that came in as a string. So do you get it?
Yeah. Yeah.
Okay, so we're going to come here, and now we're going to declare our rows and calls as integers. Then these arguments, we're going to pass them to our function to convert to integer. So we're going to pass them and convert them to integers, right? As well as calls convert to integer. So it means now, so our arguments are going to go to the strings. So we're going to pass them to this function convert to integers which accept a string. So then we're going to convert them to an integer. So this thing will return an integer. So that's now that's why we are now declaring this thing as an integer. So
Yeah.
you get it, right?
Yeah. Yeah.
So this means here. So here I'm going to say my size is rows. So now this thing will now run perfectly fine because rows is now an integer. So if now I try to run, I won't have that error I had before. So you get them, right?
Yeah. Yeah.
So let me cancel the third. Okay, let me cancel the third argument. Just giving it. Oh, actually, let me demonstrate that failing of conversion. Let me say here instead of saying 20 as a whole number, I will say, let me say I say 20 as an actual weight. So if I run that, You see, the conversion will fail.
Yeah.
Because 20 cannot be a whole number. Okay, you see it.
Yeah. Yeah.
So yeah, you need to know that function. Not hard to memorize. So let's say we have a program now, and our program has to have the number of rows and the number of columns passed from the command line arguments. So let's say those rows and columns are very important to our program. Without them, the program is useless. So it means like before starting with our program, we need to check if all those arguments are there because they are all important and they are all needed, right? So
Sorry to interrupt you. Uh, I just want to ask, are we going to do like an actual game for for an implementation of what we just learned about 2D arrays, pointers, and all that?
yes, I just want
Okay.
to explain these things before we get to the game.
Okay. Sure.
So so I said, let's say our program now needs to have number of rows and number of columns,
Yeah.
right? So
Yeah.
let's say these things they need to be passed from the command line argument, and they're very
Yeah.
important to our program.
Mm,
So it means without them, we cannot continue with our program, right?
mm,
So before we start our program, we need to check if all those arguments are there. So can just say so we can just do that by checking if is axis is not equals to at the moment. In order to have the number of rows and the number of columns to be passed, the size will just be 3. So if the size is not 3, it means those number of arguments are have not been passed, like they're missing, right?
mm.
So it means we cannot continue with our program. So just going to put another message. Let me say invalid number of arguments. And here you can just specify the rows and the calls. Then yeah, you have to exit because if you don't have everything to run your program, you can't continue with the program. So this is how you will check. So let's say instead of passing the 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 rows and the columns, you only pass the rows.
Mm,
Okay, it means now axis will be 2,
mm.
right? So if I try to run this, you see it will say invalid number of arguments because you only pass in the rows. So in
Yeah.
order for the program to run, you have to have the rows and the columns.
Mm.
Okay. So this is how you do it. So but then there's another short way to do it, which is called assertion. Have you done it in class yet?
We did it in the last tutorial session, but it was a bit fuzzy.
So with assertions, so it's like I got it. Now our program needs to run if and only if the number of arguments are 3,
Mm,
right? So with assertion, you're actually giving the program a condition. You're saying, program, if this condition is true, run your program. But then if this condition is false, don't
mm,
run the program.
mm.
So in order to use assertion, we're going to include this library, include its assertion.h. Sorry, I think it's asset.h. Yeah, it's
Uh,
asset.h.
and also one question, why are you including libraries in the header file? Aren't we supposed to include them in the implementation file and main only?
Yeah, because I got here we're going to include this header file, right? So this header file automatically will come with this with these libraries included. So the reason why I'm doing them here is because, like for example, actually don't know how to explain it to you, but then so in the header file, let me say for example, here we want to use rent, right? So in order to use rent, we have to have stdlib.h, right?
Yeah.
So if I declare this, if I include this in the header file, we won't be able to use this file because it's not going to be included anywhere, right?
So basically, if you use all these libraries in the header file, you don't need to repeat them in the implementation file.
Yeah, here I can just remove this using stdlib and remove this thing. So automatically, by including the header file, these things get included because we included them in the header file.
Oh, okay.
You just need to do
Can
them
I do
once.
that in an exam or in a test?
Yeah, of course.
Okay, sure.
Okay, we are on a session, so we need to have this library asset.h.
Yeah.
So as I said, we're going to say asset, right? Then you're going to give a condition. So this condition, in order for your program to run, this condition needs to be true. So at the moment, our program needs to have a the arguments need to be rows and columns. So it means that the size of axis must be 3, right? So our program can only run if axis is equals to 3. So let me comment this out. So if axis is not equals to 3, it means our program won't run. So the moment our arguments are not 3, so our program will not run. So the assertion will fail, right? But then let's say we have the valid number of arguments 30. So axis will be 3. So our program will run successfully. You see, so the program will now run successfully. So this is how assertion basically works. You get it, right? Can you still hear me?
Yeah, I can hear you.
So let's say you also want to output a message. So after the condition, you can just say and then you write the message after. So this will basically show the message. If this condition is false, this will also display a message here. So let's say our number of arguments are not correct. So it means that the assertion will fail, right? So you see assertion failed, then the messages get displayed here. You see it, right?
Okay.
So okay. So now we are done with command line arguments. So now we can do an actual game. So I think the best example is to use that one from Practical 8, right?
Okay. Yeah. Well.
You can use this one.
Yeah. Or we could do the ninth one.
Oh, you have Practical 8, Practical
Sorry?
9. You have
Yeah.
Practical 9.
Yeah. There's a ninth practical that was uploaded.
Oh, I haven't seen it. What is it about?
I think it speaks about like some kind of virus that escaped from the utopia world, and then you need to catch. So basically, those viruses, when they catch something, they make that thing transform into it. And I don't know. Should I send it to you?
Sorry?
Should I send it to you?
Yeah, you can.
Yeah. Let me just quickly log into.
Ngicabanga lo 5 years ayinisebenzelanga nga-next. Uphakela ukutya kwabanye, ufundisa abanye wena. Ufundisa mna, wena. Hayi bo, yonke mina itshela ujola nakho interaction iyangifundisa. Yonke uhamba abantu ngiyangifundisa. Angithi nami ngiyakuthengela lokhu ngikufundile. Angithengi, uyafundisa. Yeah.
So
I'm just saying it on WhatsApp.
yeah. There you go. Yeah, check it out.
How's it? So the past papers. Okay.
Yeah, well, they send it to us as a.
Blah, 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 blah. Okay, Grigo. An accident has occurred in the Utopian nanomaterial research facility, releasing a self-replicating substance called the Grigo, which threatens to spread and convert everything in the area into copies of itself. Okay, the Grigo will move into an adjacent square with a fixed probability. If one of the squares was occupied by something else, then all of the gray goo will pause from between 1 and 3 turns before continuing its expansion. So your job is to move your character to the edge of the map and save yourself before the goo consumes you. Player, the black circle, an empty square space, then occupied square, double cycles. Oh, this is the player. Empty space, and this is the player. It's black circle, empty squares. First this space, then occupied squares, the double circles, right? Then the goal filled is the filled squares. This one in blue. Okay. So before we start, I think let us just go and create values, create characters to represent these things, right? Like in our world, we have spaces and we have a player and we have the goo, and we have occupied squares. So let us first create some values, some values to represent those objects and some characters to represent them too, right? Oh yeah. So we have a space. I'm going to call it. Oh, it should be a constant. I'm going to say is def space. So a space is going to be represented by 0. Then we have a player.
What does def space stand for?
In this case, I'm actually saying like it's default space. So the value of default space is 0. So def represents def.
Okay.
Represents default.
Okay, so just an empty space.
Yeah.
Okay.
Then we have the glue. We have the glue. Let's say it's number 3, right? It's represented by the value 3. Then we have the occupied space.
Oh yeah. Are we gonna use enumerations and record structures?
Yeah.
Okay.
Occupied space. So occupied space will be 4. So here, instead of declaring these values like this, we can use enumeration, right?
Yeah.
So maybe it's better to use enumeration, actually.
Yeah.
So I'll call it enum and say int characters. Just call it like that. So in here I'll have my values. I'll have the space and the player, the glue, and the occupied space. So automatically the first value we put is going to have a value of 0, then it will be 1, 2, 3, as in that order. You already understand enums, right?
Yeah. Yeah.
Okay, so I'll cancel this one out.
Okay.
And for you can also have an enum to contain the error code.
Yeah.
Error code. Then let's start with success.
Mm.
Then we have an error code for the failure error code for when we have failed to convert something to an integer. So I'm going to call it error
Conversion.
conversion. Then an error for, okay, give me a moment. Hello. Yeah.
Hello.
Error what? Okay.
Can you hear me?
Yeah.
Can I ask regarding track 9?
Can you do what?
Can I ask something regarding track 9?
Yeah. But right now I'm in a session.
Nginenkinga and I feel like I'm wrong with this, I'm wrong with that. So I want her to explain everything to us.
Is it fast or?
Please come in. Yeah, it's a 2 minute thing.
Okay.
So for the fact we're supposed to get from the user the number of regions and months. I can't find a way to resize the grid like for the number of regions and the number of months separately because the number of months is for each region. So every time I resize, it does the same thing for the regions and months.
Actually, you must send me it, then I will try to explain it to you.
Okay.
So here is the enum for error code. So we're going to start from -2, and automatically this will be -1. This will be 0.
Okay.
You get them right?
Okay.
Then here we just use them error conversion. Then in here will be here it's supposed to be error is invalid for invalid number of arguments. Then here instead of return 0, we can just say success.
Mm.
Okay. So yeah. Okay, let's focus on this. So this is our characters, our values to represent those characters in the world. Now we're going to make an array of characters. It's supposed to be const. Characters. And at the same time, I'm going to specify my characters. So at index 0, it's going to be a space. So I'm going to make a dot. So these things will correspond. The values here will correspond with the specific characters. And for the player, we will show P. Then for the GUI, will represent the character for GUI as an at. And for the occupied, we'll just use an O. Do you get it?
Yeah, well, you could use a capital O for the occupied space.
Let me use a capital.
Yeah.
So yeah, each thing will correspond. So you see that they correspond 0 for dot, and this will be index 0, so they correspond.
Yeah.
Okay. Let's continue reading this. Okay, we've done that. So they're saying in the game, you will need to move a player control character around the two-dimensional playing area. Your logic must be placed in the GUI space. Okay, let's change this space to GUI space. Okay, then that's under initialization, that's saying the size of the environment is specified via command line arguments. So this means our rows and columns must be specified here. So let's just say 20 and 20. Okay, this is correct, right? So I'm going to declare those variables to contain those number of rows and number of columns. So basically I need to convert them to integers. Cause convert to integer. So my world is the number of rows will be 20 and the number of columns will be 20. So now let's declare our world. So it's going to be a 2D array. So I'm going to call it world. Then here I'm going to declare functions to allocate memory, to deallocate memory, and to display the world. I'm going to make them a void function. The function will be allocate memo. Then I'm going to pass in my world. Then world you must always pass it by reference. Then I'll pass in my rows. Did they say you must use record structures? Or is not important? Have you learned them yet?
Yes, we have.
For now, I think we'll just let us not create them, because We have to explain them and stuff, and we don't have time. So I just create a function to allocate memory. I'll pass in the world, the rows, and the calls, and I will have a function to deallocate memory, and I'll pass in the world, and I'll pass in the rows, and I'll pass in the calls. Then same time, let's make the display function to display the world. So same as this one. So for the deallocation, we don't need the number of columns, we just need the number of rows. So, okay, then I'll need the function to initialize my world. Just need the world, number of rows, and the calls. We are still on the same path, right?
Yeah. So basically, where are you creating the world in initialize world, right?
Yeah.
And then you're displaying it in display world, allocating memories. That's where you're creating the 2D arrays.
Yeah.
Okay.
Oh yeah. I'm going to declare it here. Then I'm going to pass it in the allocate memory to allocate memory and stuff. Just going to pass it.
Okay.
So let us implement those functions. So for allocating memory, so we pass in the world. So we're going to say world is equals to new. So remember, it first need to point to an array of pointers. The size is rows. Then we need to loop through the array of pointers. Array of pointers. We need to go through the array of characters, the array of pointers, and allocate memory for each pointer. Then each pointer will point to an array of integers, which size calls. So allocation of memory, you still remember it, right?
Sorry.
So the allocation of memory, you still remember it, right?
Yeah. Yeah. So basically, you said, so basically, inside the braces, you didn't say int pointer world because you already specified it in the function, right?
Yeah, because I'm passing it. So here I'll declare the world. Then to allocate memory, I'm going to use that function. I'm just going to pass it here, world, then passing the number of rows and the number of calls, just like that. Then this function will allocate memory for my world. Just need to pass it the world and the number of rows and the number of calls. That's what I'm doing here. Do you get it?
Yes. Yes. Yes.
Then let's do initialization. So initialization is where we place the values in the world. So at the moment, we're just going to place spaces everywhere. So here we're going to place everything here. We're going to place the player, the spaces, the go, and the occupied in this initialize world function. But we will firstly we place spaces everywhere. So let me say place spaces everywhere, and afterwards that's when we will place other things. We'll do it later. For now, let's just place spaces everywhere. World R and let's see. So we have a value for space which is 0. We save it in the enum. So we're going to use it. So do you understand what we did now?
Yeah.
So yeah. For now we're just placing spaces everywhere. We'll place the other things as we go on with the program. So now for the allocation of memory, so remember we need to delete all the pointers. We have an array of pointers and we have the pointer. So we have to delete everything, every pointer. So we're going to go through the array of pointers first, then we delete each pointer in that array of pointers. So this is me deleting each pointer in the array of pointers. Then after deleting each pointer in the array of pointers, I'm going to delete the whole pointer.
Yeah.
You get it right?
Yes.
So for the display, same logic as last time. I'm just going to say R equals to 0. I'm going to look through the array of pointers and the array of integers. So remember we have this array of characters here. So I'm going to use it characters. Then my index will be the world. Let's see. Do you still understand this thing?
So basically, to start with the world R, index R and C, what do they output basically? The world R and C.
They will return whatever is in. It's going
Because
to
we haven't
return
done that part yet.
Yeah.
I'm saying we haven't done that part yet, what the world R and C outputs. So basically what you're saying is characters is P, @ and everything will be displaying, it'll basically display a grid of P's and ats and whatever you said in the characters thing.
Yes. So at the moment you see in initialization, just put zeros everywhere. So this thing will return a 0. So it means my whole grid will be displaying dots everywhere because the characters array at index 0, it's a dot, right?
Yes.
Okay, this is basically the function to display the world. So in here, the allocation is done just right before we terminate our program. So the allocation of memory, I'll deallocate here and passing my rows. So after allocating memory, I will initialize my world. Need to pass in the number of rows and pass in the number of columns. So now, if I display my world now, we'll only see spaces. By spaces, I mean the dots. The dots.
Sorry, could you
Okay.
Okay, could you please go back to the implementation file and see where I just want to see where we did put the dots. To the
This one,
implement.
right?
Yeah. Yeah. Now I just want to see the chaser.cpp. Where did we implement the points?
Where did we implement the point?
Yeah. I think just in the what is this initialize world? Can I see the function?
In the initialize world, we only
Okay.
placed spaces everywhere.
Yeah.
So you get it, right?
So spaces stands for dots. Yeah. Okay. Cool.
So the display, you get it.
Yeah, I do.
So here, of course, the game. So for now, let me just. I agree. We need to run. We need to run our game in a do while loop. So let me, in the meantime, do it. So I will have a char for storing in the option. Then bool. Normally you say boolean continue. It goes to true. So I'll do it while boolean continues. Ouch. And I will display my world here. Before I display my world, I want to clear the screen. I hope I'm not going fast.
Yeah, no, that's okay. System CLS.
Okay, then after that, let me display my menu. I don't know what my menu is. Let's say here, choose W for up, then S. We will change it if you want us to do something else. Then A for left. Then what's this? D for right. Line. You can see how Q for create. Yeah, just want to prompt the user for the input. Which is option. And this here will be where we do the switch and stuff. For now, nothing happens. Okay. Let's see what they want us to do. So the size of the environment is specified via the command line arguments. Okay, we've done that. Then every empty space has a 12% chance of being occupied. Okay. 2 squares from the center of the area. So they're saying every empty space has a 12% chance of being occupied. So 12% chance. Okay, let's just move on before we do that. The player is placed randomly in a location 2 squares from the center of the area. then the center square is occupied by the gray goal. So I think the gray goal, when the game starts, we only have one gray goal at the center, right? Then the player is 2 squares, random area, 2 squares from the center of the area. Then every empty space has a 12% chance of being occupied. Okay. So in the initialize world. So I think let's just start by placing the gray goal because it's simpler. Place is the goal, right? Let's place the goal. So the center. So let's say our center is going to be represented by, we have a center row and a center column. So we can just say, for the center row, we can just say C at center. And let's just say rows divide by 2. Do you think it's better, right?
Sorry?
So it's better to say for the center row and the center column, for the center row, we just say rows minus 2.
Divided by
do
2, yeah.
Do you think we should say rows minus 1 divided by 2?
Y minus 1. Oh, because it's inserted 0, yeah.
Yeah, I'm thinking because that from 0. But then either way, I think let's just use minus 1 to be on the same side, on the safe side.
Okay.
So yeah, then we're going to place our gray goal. So at the center, I'm going to say R center, then C center, and we're going to place our goal. Okay, if you run our program, should be seeing a goal at the center. Is a problem. Oh, remember this thing might return a decimal place. So I'm guessing here maybe a decimal place is being returned, but then that's not possible. Okay, let me check. So the goal 1, 2, 3, it will be 3. Then here we're placing it. So this thing should work. Let me try to cast it. Okay. So we have a problem here. So do you think you know why there's a problem here? There's the goal at the, so I basically put this thing in bracket, rows minus 1 in bracket, then divided by 2. I think that was the problem. So I think it was saying rows minus 1 over 2. I think that's why there was an error. Did you get it?
Yeah, I do. So basically, you just converted it from being a double, because basically what you were saying there is that when you divide by 2, this is like a decimal, so that was making it a double. So you basically turn it into an integer.
Yeah. And I think like let's try to remove these things. Let's see if it works. Cause we should. Cause when we have this int, I think maybe even if this thing is a double, but then the moment this variable here
This
is
is
an
stored
int,
and yeah.
yeah, it will cut off those decimal places.
True.
So yeah. So is it at the center? 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is 10. Let's just
Wait,
let's just
did you set the number of rows in main and columns?
sorry.
Have you set the number of rows and columns yet in main?
Yeah, I did. I did it here. I got them from the
I'll say
from the
20.
command
You
line.
said 20, 30, right? So that yeah.
Let's check. Oh yeah, I set them back to 20 and 20.
Okay,
I made
but
them
that's
20 and 20.
400. So there's like 400 of them. So column.
So far you get everything right.
Yeah, yeah. But just a question though. When you after where are we? Yeah, you're saying in R center, you're doing that outside of the loop, right?
I did what?
You said so you basically said world R center C center equals to go. You said you did that outside of the loops, right?
Yeah, after the loop. So yeah, this is so for this loop is for placing spaces everywhere. Then now I focus on placing the glue. I don't do it in the for loop.
Okay.
So okay, I think let's move on. Placing the player. Let's place the player. Okay, so the player. Let's see how the player plays. So the player is placed randomly in a location 2 squares from the center of the row. 2 squares from the center of the row.
The area.
So 2 squares, maybe it's here, right? So let's say this is the center, then two squares after, then it's here. It can be this side or this side. Right? That's what I assume. Let's check. The player is placed randomly in a location 2 squares from the center of the area. So, you want to ask something?
No, I was just trying to think. Yeah, yeah.
So 2 squares from the center, 2 squares from the center. So if let's represent our center as where the goo is. So 2 squares after the center. So if we're going to the right, 2 squares after the goo, it's here, right? Then yeah. So how do we do that? So it needs to be random. So okay, here we have the center, right? And it needs to be random. Oh my God, random. Okay, let's think about it. Random.
Okay. So
Player rule. So I'm still thinking about it. So if I were to generate a random number, and then the upper bound R center, then the lower bound be R center minus 2. Does it make sense? Does it?
Wait, so you said generate random. That's for the row. You said R center. R center, is it like your minimal value?
It's the up. This is the upper bound. This is the lower bound. R center is the max and R center minus 2 is the minimum. So random number, random row, two squares after the center. Two squares after the center. Okay. Let us just check what this thing will do. I want to check where it will be placed if we were to do it like this. And we will see from there if we are on the right track. Let me just place my player at P row and P call. Just place my player for now. Let's just check where it is going to be. Should be, oh, and we should remember that it must be, oh, so this option is not effective. So does this mean it? Okay, can also be to the right. So we're heading somewhere. Okay, to the left side. So I'm realizing that my role is with the code that we wrote is always going to be either here or here, like two steps ahead. Oh, let me say one step ahead. So how can we change this code so that the player does not land on those first two squares? It must be after the two squares. So how can we do that?
Say -3.
This is the lower bound. Okay, but then when we say -3, this what, so like,
oh,
I think,
okay,
I think the problem is like this is the center, right? So the player will be either on the center or two steps, bit like, let's say this is the center, then these are the two steps, right? So it'll be between here and here and here, but then we want to put it outside at those two steps and where the player is. So let's think about the row. The rows here is row 1, row 2. So basically we wanted to put between, you see where I highlighted with white. So we wanted to put it here. So this is from the lower bound. No, let's say this is the center, and we wanted to put it here. So okay, so let's focus on the rows. So the row, I feel like this shouldn't be a random number. Then let's just think about it for a moment. So I think the upper bound should be from here to here, which is, so the upper bound is row center minus 3, then the lower bound let me check something. One, two. Wait, is it going to be always the same value? Okay. So it's going to be the same place. Maybe we can pass it for now, because I will try to find a way to do this, and I will give it to you.
Okay. Sure, no problem.
Oh yeah, we will. I will think about it. Kind of hard. Gosh, our session should have ended 8 minutes ago. So maybe I will try to do this program, then I will send it to you when I'm done. That fine with you?
Well, I don't know. The thing is, if you do it without me being there, I would have questions, and how would I reach out to you? Um,
Ah, you just text me, because I have another session. My next session should start at 5:10.
hmm. Okay. Okay. It's okay. Thank you.
I'll send you the thing. Recording. Okay, it will